Okay, so we're looking at homework from section 4.3 today. This is question number 8. Let's go ahead and read the problem. We want to find the indicated probabilities using the geometric distribution, the Poisson distribution, or the binomial distribution. Then determine if the events are unusual. If convenient, use the appropriate probability table or technology to find the probabilities. A glass manufacturer finds that 1 in every 250 items produced is warped. Find the probability that A, the first warped glass item is the 10th item produced. B, the first warped item is the first, second, or third item produced. And C, none of the first 10 glass items produced are defective. So we're going to start with part A. The first thing we need to do is decide what kind of distribution this is. We're looking at the probability of finding the first occurrence of something, in this case, the first warped item. When we're looking for the first occurrence, that means it's geometric. So we're going to be using the geometric probability formula. And that geometric probability formula is the probability of first success on trial x, given by q, which is the probability of failure, to the x minus 1 power, times p. In this case, our probability is 0.004. So where did that probability come from? Well, we were told that 1 in every 250 glass items that's produced is warped. If you plug in 1 over 250 to your calculator, you find out it's 0.004. Now you can use the 1 over 250 if you want instead. It's just easier to put the decimal into your calculator when we're trying to find our final answer. If p is 0.004, how do we find q? Well, q is always 1 minus p. So if we did 1 minus 0.004, we would get 0.996 for q. And in this case, for part A, we're looking for the probability that the first warped glass item is the 10th item produced, so that means our x is 10. So we're going to use our formula and these values. We get the probability of the first warp on item 10 is given by 0.996, that's the q, to the x minus 1, that's 10 minus 1, times p, which is 0.004. Now 10 minus 1 is 9, so it's 0.996 to the 9th power times 0.004. If we multiply that out, we get 0.0038582826. Rounded to 3 decimal places is 0.004. And that's your answer to part A. Let's look at part B. So now what we're going to do that same process, same formula, but we have to do it 3 times. We have to do it for when x is equal to 1, when x is equal to 2, and when x is equal to 3, and then we're going to add them all together. So let's start with the first warped item being the first item. That would be 0.996 to the 0. Why 0? It's x minus 1. If the x is 1, 1 minus 1 is 0, times 0.004, which is 0.004. If the first warp is on item 2, that's going to be 0.996 to the first. Again, x minus 1. 2 minus 1 is 1. That's why that's the first power, times 0.004. Gives us 0.003984. And if the first warp is on item 3, we get 0.996 to the second times 0.004, which gives us 0.00396864. Then we have to take all these numbers and add them together. And if we add them together, we get 0.011952064. And if we round that off to 3 decimal places, that ends up being 0.012. So the probability that the first warp is on item 1 or item 2 or item 3 is given by 0.012. So that's the answer to part B. For part C, we're looking for the probability that none of the first 10 glass items are produced. So in this problem, we're going to use the calculator because otherwise what we'd have to do is that same idea from part A where we plug in the numbers, but we would have to do it for x values from 1 through 10. So we'd have to do 10 separate calculations. We could, it's totally within our wheelhouse to do that, but the calculator is going to allow us to do this more easily. There are two versions of the calculator. Okay, the TI 83 and 84 have undergone some software updates in newer models of those calculators, and so some of you may have two different versions of the calculator software depending on what kind of calculator you have. So we're going to talk about both of those versions of the calculator. They do both start off the same way though. So you're going to press the second function button, which is in the upper left-hand corner of your calculator, and then you're going to press the vars button, which is near the directional keypad on the upper right. So it's down diagonally from that directional keypad. Once you do that, you're taken to the distributions screen. And you're going to need to scroll down until you get to Geomet CDF. That's the geometric probability distribution cumulative distribution function. That means it's going to add up several values for us. We saw in part B where we wanted to add those 3 values. This one's going to add up all the values we want it to. We're going to scroll down till we get to Geomet CDF, and we're going to press enter. And when we do that, this is where the two different software versions diverge. If you have the older version of the software, then what will happen is Geomet CDF will appear on your home screen, followed by a parentheses. You have to complete that. And so the way that you complete that is by first typing the p-value, 0.004, then you type a comma, then you type the x value where you want it to stop, which is 10. All CDF functions start at either 0 or 1. The geometric one starts at 1. The Poisson CDF and the binomial CDF start at 0. And they add x values starting at that value going up by 1 every time. So Geomet CDF starts at 1, and it plugs in the 1 for us, it plugs in the 2, it plugs in the 3, all the way up to the x value we tell it to stop at. And that'll be the last value that it adds. So by putting the 10, that tells it start at 1, plug in 2, plug in 3, and keep doing that until you get to 10, then stop and add all those answers together. Then you'll press enter. You have to end your parentheses. If you don't end your parentheses, the calculator gets a little bit upset because it's very picky when it comes to syntax. So if you do that and you enter it correctly, then the answer you'll get is 0.0392876265, rounded to 3 decimal places, is 0.039. Now, understand, this is not the answer, and I'll explain that further after we go over how to do the newer version of the calculator software. So on the newer version, once you scrolled on the distribution screen and found Geomet CDF and pressed enter, you would be taken to a screen that looks like this, the Geomet CDF screen. It's got a spot for P and a spot for the X value and then the word paste. So what you're going to do is where it says P, you're going to type in the P value, which is 0.004. Where it says X value, you're going to type in 10. Again, that's where you want it to stop adding. And then you'll go to the paste and press enter, and it will put that Geomet CDF 0.004, 10 on your screen, just like if you had the older version. It just fills in the blanks for you so that you don't have to worry about the syntax. And you'll still get the 0.0392876265, which rounds to 0.039. And again, that's not the answer. Why is it not the answer? Well, that would be the answer if we were finding the probability that either the first or second or third or fourth or fifth or all the way up to 10th item was the first warped item. We're looking for the complement of that. We're looking for the probability that it's not one of those first 10. So the probability that none of the first 10 are the warped ones is 1 minus the probability that one of the first 10 is the first warped item. So we actually have to do 1 minus that 0.039, which gives us the 0.961, which is our answer to part C. Okay, so then the last part says, which of the events are unusual? Select all that apply. Remember that our criteria for being an unusual event is having a probability less than 0.05. So part C here, 0.961, that's far in excess of 0.05, so that's not unusual. But those other two probabilities that we found in part A and in part B were both unusual because their answers were less than 0.05. So we end up with two answers here for the last part, part A and part B. And that's your answer.